Hello and welcome to Americans Learn. My name is Lauren and today I am looking at a video from Real Science. This one is the insane biology of the cicada. Because the cicadas, y'all, are coming. I'm not entirely certain when they're supposed to start emerging en masse, but I know that I'm in an area where they're supposed to, like, both the 13 and the 17-year ones are converging at once, and there's supposed to be a lot of them. So I'm like, you know what? Let's learn a little bit about these little guys. I remember the first time, like, the big cicadas, like, swarm showed up, and my mom terrified me. I, like, literally thought I was gonna have to, like, have an umbrella with me at all times. I thought they were gonna be flying into my face. I thought I would be, like, walking on just, like, mounds of cicada bodies on the ground. I thought it was going to be, like, this horror movie type thing, like cicadas flying into my mouth. Like, it was awful. I had, like, so many, like, horrific, like, ideas about what the cicadas were going to be like, and then it was fine. So, but there are going to be more of them this time. So I don't know exactly when they're happening, but I'm curious to see what the deal is with them, because I would like to go into this knowing just a little bit more. So, let's begin.
By the Real Science Patreon page. Join us over on Patreon for bonus content and community perks you can't get anywhere else. This spring, the eastern United States will experience an invasion from a creature.
When did this come out? I thought, because it's definitely the Midwest. 2 weeks ago. So the Midwest too.
Emerging in numbers not seen in centuries. They'll come in the night, bursting through the ground like an army of the undead. They've haunted American settlers for generations, with early colonists calling them a plague and even using them as an indicator that war was coming.
Oh, okay. I'm actually curious, though. I am going to take a quick look at when do the cicadas come? Illinois. So, yeah, late May or June is when it looks like they're supposed to show up. 2024, late May, early June, depending on the location. All right, they emerge when the soil temperature is at a depth of 8 inches reaches 64. So usually after a rainstorm. So we shall see. Late May or June. Now let's see if I can find the tab that I was using in order. There it is. That's what happens when I go into
with their red eyes and papery brown husks that they shed before achieving their final form, it's not hard to see why they inspired so much terror and awe. But periodical cicadas are not zombies
There's a face.
Or predictors of war.
I wasn't expecting there to be a face. I don't know why.
Or even a ravenous plague of locusts. They don't even have teeth, and they can't transmit disease, so they're basically harmless to humans. Besides being very, very loud. The 7 species of periodical cicadas in the United States all belong to the genus Magicicada, and they're unlike any other organism. Depending on the species, they spend either 13 or 17 years underground. No light, no movement, and very little food. No other insect on Earth takes this long to develop. When they're underground, they survive off eating xylem, which is liquid from tree roots. And then, on one momentous spring night, millions and millions of them emerge at once. An unthinkable number of organisms living their lives in complete synchrony. Then they climb up whatever vertical surface is closest, and then they tear open their skin and burst out in their final winged form. All told, there will be trillions of cicadas emerging around the same time across the US. And once they've left the ground, the real party gets started. The male cicadas gather together in chorus centers to broadcast their call for the females. This song is one of the loudest known among insects, and is produced with an organ that no other insect has. Love them or hate them, it's hard to not be impressed by these intense, loud, and crunchy guys. How is it that they can tell time so precisely?
I wasn't expecting the squirrel. I will say, because I was in elementary school the first time this happened, and they did have the 9-year-olds were convincing each other to eat them. Just crunch. I never did. But I knew people who did.
How are they so loud? And why did they evolve so it takes decades for them to fully develop and then emerge all at once?
Let's find out.
Before we get to the life cycle of the periodical cicadas, first we have to review the difference between the species and the broods. All the nomenclature gets a little tricky. There are 7 species of periodical cicada, and they fall within 3 groups: Decim, Cassini, and Decula. The Decim group was the first to split off from the others about 3.9 million years ago.
Wow.
Then, 2.5 million years ago, Cassini and Decula split off. And over time, each of these species evolved to have extremely lengthy developmental stages, taking 13 or 17 years instead of just the 1 year that is required for many other cicada species. Cicada broods, on the other hand, are groupings of periodical cicadas that simply come up at the same time. These broods are usually made up of several different species. To understand more about the development of cicadas, I spoke with Dr. Chris Simon.
So there's a lot of insects that live longer, maybe even some beetles that could live 50 years. But in terms of development from egg to adult, these are the longest known life cycles.
But why did some evolve to be underground for 13 years and some for 17? Because as these cicadas were evolving, something else was happening in North America. From 2.6 million to 11,700 years ago, continent-sized ice sheets formed in North America, which then underwent repeated expansion and contraction. Researchers think the growth and dissipation of ice may have affected how these species split off from one another, since the 17-year species are all more northerly than the 13-year species. In other words, maybe they were first geographically isolated by glaciers, and then they adapted to have longer life cycles because they were in a colder climate. This map shows the geographical distribution of all the different broods that we currently know about. And right now, in the spring of 2024, both a 13-year brood and a 17-year brood are coming up.
Yeah, look at that map. I am not.
And right now, in the spring of 2024, both a 13-year brood.
Look at this. Right here. That's where I'm at. Right in the middle of it all. Almost. It's just a lot. It's gonna be a lot. It's gonna be so loud.
Brood and a 17-year brood are coming up at the same time. Brood 19 is the largest of all broods, extending from Maryland to Georgia on the East Coast and from Iowa to Oklahoma in the Midwest, and it includes 4 13-year species.
Wow.
And in northern Illinois, Brood 8 will be coming up, including 3 17-year species. You won't be able to see all 7 species come up as adults at the same time again until 2037. And even though 13-year cicadas and 17-year cicadas develop on different timescales, their life cycles are surprisingly similar. Cicada nymphs go through 5 instars, or developmental stages. But because those 5 stages all happen underground, they're pretty hard to monitor. An entomologist in Connecticut, Chris Meyer, conducted an incredible experiment to see.
Several Chris's involved with the cicadas, huh? I mean, you would have to like make it be your whole life. It would be like that pitch experiment, that like pitch dropping experiment. Like you would have to make it be your life to monitor the life cycle of these cicadas.
What was going on beneath the soil? Starting in 1979, he dug up 100 cicada nymphs every single year for 17 years. He noted the amount of time it took for the nymphs to move from one instar to the next, observing that the older they got, the longer it took for the majority of them to transition into the next developmental phase. He also noticed that they weren't all growing at the same rate, an interesting observation that tells us their timekeeping is probably not tied to how big they get. Near the end of this 17-year experiment in 1995, he noticed that the nymphs' eyes changed from white to red, signaling that they would be emerging the next spring. When the nymphs reach their 5th instar and get to the 13th or 17th year of their cycle, they wait for the soil to reach the right temperature. At their depth of 20 centimeters, the soil needs to warm up to 17.9 degrees Celsius or 64 degrees Fahrenheit, which happens around April or May. Then, one evening, they tunnel their way through the dirt, sometimes even creating mud turrets, which are basically little towers that rise above the ground on their way out.
A spider on that
They
one.
climb onto whatever vertical surface is closest to them and begin the final stage of development, molting. And this part is a little bit gross, but also super cool. Their skin splits along the thorax, what we would think of as their back. Their head, and then body, and then legs wiggle free, while the lining of their breathing tubes or trachea are turned inside out.
Oh.
Once they've fully emerged, their tiny wing flaps must be inflated like little balloons. Fluid pumps through the veins of their wings, making them expand. Once they've fully emerged from their shell, their exoskeleton...
The little like eyes are like kind of starting to bulge out a little bit too, which is interesting. I bet it's one of those things that, like, there's so many billions and trillions of them because a lot of them just get murked immediately by like birds and squirrels and spiders and like all sorts of other stuff. Lawnmowers.
Hardens and darkens. And then they're ready to start the courtship process. But despite how much we've learned about them, periodical cicadas still hold one of the biggest mysteries in ecology.
Once they've reached their year of emergence, we know what triggers them to come out, the ground temperature, but we don't know exactly how they keep track of those years. And we don't know exactly.
I was just sorry. I'm trying to see her necklace. I feel like it's cool. Like the silver one, her shorter chain. I feel like it's cool, but her hair's in the way. Doc, move your hair. I want to see your necklace. I think it looks cool.
How they know when to come out.
It almost looks like a little like cow skull or something.
There are thousands of species of cicada around the world, and the vast majority of them have yearly cycles. Yes. This even includes a lot of cicadas in North America.
Yeah, so like, I mean, like, especially in the South too, like you hear a lot of cicadas every single summer. We definitely get them here too every year, but you don't see them so often. Like, I feel like I hear them constantly, like all summer, but I don't see them. So like this is the time where we get to see them for real.
There are only 2 other species of periodical cicadas in the world. In northeast India, there's one known as the World Cup cicada for the way its cycle ties to the football championship. And in Fiji, there's one with an 8-year cycle. You might notice something about those other 2 species.
The green one.
They're pretty.
Ooh, those are cool looking. I like that the Fiji one kind of looks like it's got Batman symbol on it. Oh, those are really pretty. I like those a lot. They're much prettier than the ones we get.
Cycles are both based on 4-year intervals. But the North American periodical cicadas have 13 and 17-year cycles,
a weird one.
Which don't fit that pattern. Except that when cicadas lose track of time, they tend to come up either 4 years too early or 4 years too late. One researcher has hypothesized that cicadas might count in intervals of 4, even though they sometimes come out in odd-numbered years.
If they're ready to come out early, they'll come out early, but only in a 4-year window. They'll come out 4 years early, or sometimes if they're not.
Okay, yeah, I can kind of see her necklace. Maybe it's a cicada. I don't know. It's cool looking, whatever it is.
Ready 4 years late.
But even if cicadas could count up to 4 and group those numbers together, how would they know when a year had passed? Sure, they can tell the temperature is changing to a certain extent based on soil temperature, but being underground insulates them from the more extreme seasonal variations that happen in the air. They also can't see any light, so they have no way of knowing when the sun rises or sets. One group of researchers proposed an interesting hypothesis, that the cicadas are counting the seasons based on the trees whose roots they're feeding from. If you remember, we mentioned that cicadas drink xylem, which is one of the 2 fluids that trees produce. You're probably more familiar with the first, which is sap, or more specifically, phloem. It's a thicker liquid and is far more nutritional. Xylem, meanwhile, is mostly water with low levels of minerals and other nutrients. Xylem is so nutrient poor that cicadas wouldn't even be able to survive on it if not for the endosymbiotic bacteria that they have within their bodies. Bacteria that allow them to create essential amino acids from xylem. But even though xylem doesn't have many nutrients in it, the chemical composition still changes as a tree moves through the seasons, with more or less nutrients depending on the time of year. To test their hypothesis that cicadas were counting the cycles of trees, researchers potted fully grown peach trees in large pots and created 2 different light and temperature regimens for them. The first set of trees grew like they normally would, with 365 days of light and 4 seasons. The second set of trees were artificially accelerated to have twice as many days and more rapidly changing seasons.
The amount of patience it would take to be like a scientist boggles my mind. There is no way. I mean, I was never good at science, really. I mean, I find it interesting, but I don't find it very understandable. But I just, oh, wow. It would just take so much time, and you wouldn't have any, it's like, you would have to wait years and years to find out if it's gonna work, or months, I guess, in this case, but like to find out if it's going to work, and then maybe it doesn't work. Ugh, no thank you. I mean, it takes a special breed.
So that they'd react as if 1 year were actually 2. And this part of the experiment was pretty successful, with the accelerated peach trees leafing and flowering twice in a year rather than once, though they only produced fruit once.
Oh.
The researchers also collected 130 cicada nymphs, who were in their 15th year of their 17-year cycle.
Okay.
100 of those nymphs went to the trees on the accelerated time scale.
That explains. Okay, I was like, how long did they have to wait? Okay, makes it on the 15. The 15 cycle makes sense.
And 30 of the nymphs were in normal pots.
Oh.
This experiment was a little tricky because cicada nymphs are apparently hard to transport from one place to another. They have a really high rate of mortality. So only 13 nymphs survived to emerge from the soil of the entire 130 that were brought to the experiment.
Why didn't they do them equal numbers? Like, they definitely should have done equal numbers and then like doubled the, like, I don't know, that's weird to me that they didn't do equal.
But those that did survive showed something pretty remarkable. The cicadas placed near the peach tree with a normal cycle emerged at year 17 as expected. But the cicadas that were placed near the peach tree whose cycle was sped up by 2 emerged exactly 1 year early, because in their minds, 17 years had passed. This seems to suggest that the cicadas are using the trees to mark time, but we still don't know how they keep track of whether it's been 1 year or 2 or 5. There is likely more going on beneath the surface than we know.
Some scientists believe there's also some sort of communication underground close to the time of emergence, but we don't know. Nobody's tested that so far.
The other piece of uncertainty is why they spend so long underground and then come up all at once.
Some researchers have hypothesized that their diet of xylem is so terrible that they just take a really long time to mature. It might also be an effort to break their connection to predators. Pretty much everything eats cicadas, from birds to squirrels to your pet dog. So it makes sense for the cicadas to emerge in huge numbers and have irregular cycles of emergence. Because they stay underground for so long, predators don't have life cycles linked to the cicada's growth, so no predator gets used to them as their primary food.
Right. Okay,
and because
they're an extra, it's their treat, but they're not something that anyone else depends on to live. Okay, that tracks.
They're so numerous, even if a ton get eaten, enough still survive to mate. And that mating process is the next part of what makes cicadas so cool, or profoundly disturbing, depending on your point of view.
Okay.
One
time I did find the first time that this happened, I was playing with in the pool with some friends, sprinkler, whatever. When I went back to get my shorts, there were some cicadas mating on it. I was like, not on my shorts, boys. Or folks, I guess. Not on my shorts, get off.
If you live anywhere near cicadas, you probably know that they are really loud. Really, really loud. In fact, if you get close to a tree filled with male cicadas, the sound levels can reach 100 decibels, which is approximately the same intensity of noise as a hairdryer, a forklift, or a subway train. It's such a loud sound that researchers...
I'm also just a little bit floored just now that a hairdryer and a subway are on the same level. It's kind of crazy.
Researchers have hypothesized it might negatively affect human cognitive function, though the verdict is still out on that one. But the cicadas aren't being noisy just to annoy all of their neighbors. It's an essential part of their mating, and it's different from any other insect. Crickets and katydids all produce their chirps by rubbing their back legs together. Male cicadas, on the other hand, have special organs called tymbals that allow them to produce this screeching sound. One tymbal appears on each side of the abdomen and is connected to the tymbal muscles inside the cicada's body. When the muscles rapidly contract and release, they pull on the ribbed tymbals, causing them to click and resonate against the air sacs in their thorax and abdomen.
So what I'm hearing is that male cicadas have like the most intense core workout of all time.
The rate at which they click and the size of their body changes the sound of their call. Because they have 2 tymbals instead of just 1, and because they're capable of pulsing the tymbal muscles as many as 300 to 400 times per second, the call is extremely loud, despite how small they are.
Wow.
And all of the 17 years...
She said that so casually, 300 to 400 times per second. I'm like, no, you have to, like, hit that a little harder, please, and thank you.
Species have different sounding calls. Magicicada septindecim makes a call that sounds like the word pharaoh. Magicicada cassini makes clicks followed by a buzz. And Magicicada septindecula just has a string of short chirps that last for 10 to 30 seconds with each round.
I will say that the one that sounds like a pharaoh, like, I'm like, sounds like it says pharaoh. I got this, it sounded like it didn't real, it's basically how when like ghost hunters will be like, I heard it say what? And the actual thing that was, it's like, it didn't sound like it said anything. Why are you telling me it sounds like it says a word? Like, it's like, you can hear it because you've been told that's what it sounds like. But it's like, if you really just closed your eyes and you didn't listen to what they said it sounded like, it just, like, that doesn't sound like anything. But they'll be like, it says what? Like, I don't know. So it's like, that's what the pharaoh thing kind of reminded me of. It's like, it didn't really sound like a word, but you can kind of hear it because it's like, oh. Like, it sounded just like that too. So it's like, maybe they're like football cheers. I don't know. Like,
the difference in those calls is part of how females know they're mating with the right species. Always a nice thing to get right. When she hears this chorus, a female cicada will approach a male cicada and signal her readiness for mating with a specific wing flick. The mating process takes about an hour, and then the female lays her eggs in tree branches. But she doesn't just leave them hanging there. She saws an opening in the wood with her ovipositor, which is a metal reinforced organ.
Metal?
Yes, literally metal. Researchers found everything from manganese and zinc to iron around the ovipositor, which make it strong enough to cut into the wood. She makes a cut, deposits 10 to 20 eggs, then moves forward to repeat the process on different parts of the tree branch until all 500 eggs have been deposited.
Wow.
Sometimes this does kill the tree branch, a phenomenon known as flagging. But it's not good for the cicadas when this happens either, since a lot of their eggs die too. So females have to choose wisely where to lay their eggs. The eggs mature over the span of 2 months, then break free and drop to the ground as nymphs, quickly burrowing to their dark shelter, where they'll live for the next 13 or 17 years.
Okay.
But this process doesn't always go according to plan. A certain species of fungus specifically targets the periodical cicadas. The spores fill the cicada's abdomen, rendering them sterile, but they don't kill the cicada. Instead, they seem to hijack their brains, just like the zombie fungus that attacks ants. In males, this modified behavior means they aren't just calling females. They're also doing the female wing flick signals, which draws in other males. And then the spores get passed along even further in one big creepy cycle. And that's just the start of the weirdness. The fungus also doses the cicadas with psilocybin. Yes, like the psychedelic from magic mushrooms. This tends to happen when the fungal infections are more advanced, causing the cicadas to lose the back half of their bodies entirely, including reproductive organs. Even so, the drugs make them fly around like crazy and still attempt to mate, even though they no longer have the equipment necessary to do so. By this point, you might be thinking, wow, no thank you. I do not want my yard or neighborhood to be infested by millions of noisy, creepy, mating cicadas.
Too bad! Nothing you can do about it, a beach! You moved into the suburbs. It's like, they're gonna be where they're at. You got no choice. Sorry, babe. I don't want it either, but it's gonna happen.
And you know, fair enough. But periodical cicadas are not pests. They're actually really good for the environment in a number of different ways. First, they unlock a lot of otherwise inaccessible nutrients. By feeding on the low nutrient xylem fluid and using it to build their bodies, they're sort of like herbivores par excellence. They serve as food for pretty much everything else around them: squirrels, badgers, birds, and yes, even humans. Some of their predators even have more offspring following the emergence of cicadas because they're so well fed. When their shed skins and then their bodies fall to the forest floor, that also provides a lot of nutrients to both plants and the bacteria and fungi that live in the soil. Nitrogen in the soil rises by 2 to 3 times its original level in the months after the adults die. This is great news for the trees. One study found that sycamores that were fertilized by dead adult cicadas grew about 10% more than controls in the year following cicada emergence, and this growth spurt lasted for at least 2 years. So you might think that they're obnoxiously loud or a little weird, and you definitely don't want one flying around in your house. But periodical cicadas play a vital role in their ecosystem.
That one looks cute. Like, that was kind of adorable. Those little puppy dog eyes that he had going on.
But periodical
hello, I'm a little cicada. See, he's kind of adorable.
Cicadas play a vital role in their ecosystem, and for that, we can be grateful to them. I know cicadas aren't for everyone, so if you've watched this whole video, you're probably someone who loves the natural world, weird bugs and all. My whole life revolves around loving weird bugs, frogs, fish, and everything in between. So if you're also one of these bug lovers, or lover of all things from the animal world, then you should join us over on Patreon. We're building the Real Science Patreon to be our hub of community, full of people who love animals and people who want to support this channel. All paying members get access to a group chat called the Weird Bug Club, a chat where you can discuss ideas, connect with other members, and chat with me. All paying members at the $2 level and above will also get to vote on video topics. The current poll is live right now. Members at the $5 Hammerhead tier will get early access to scripts, where you can see our thought process, notes, and color-coded chaos that turns our ideas into the videos you see here. And if you have any questions you want an in-depth answer to, you can join the Octopus tier at $10 a month. At this tier, you can submit questions now to get a guaranteed answer during the Q&A livestream on May 24th, 2024. If you've ever wondered about my background, how I started this channel, how we go about making these videos, I will give you an in-depth answer on the livestream. On top of this, the $10 Octopus tier also gives you access to our new podcast, The Real Science Creature Chronicles. In each podcast episode, me and Lorraine present a story about animals in the news. This is a conversational podcast where me and Lorraine surprise each other with a topic and then discuss and joke about the subject at hand. The first episode is an exciting update about the battle against cane toads. Listen to find out the new weird thing that scientists are doing in this ongoing saga. And if you're a die-hard fan of this channel, you can become one of the elite sperm whale tier members for $25 a month. At this tier, you'll get access to everything I've already mentioned, and get your name in the description and credits of the videos we post on YouTube. Any level of support on our Patreon is hugely appreciated. The YouTube game is getting harder. We are competing for views against short-form content and getting buried in a sea of low-quality AI-generated content. So if you like what we're doing here, signing up for Patreon allows you to support a small business of real humans doing real science communication.
Okay. So I am all for, listening to that. That will be in their description. So this video that Real Science did is linked in my description. It's linked in hers, like that's how that's gonna go. If you want to check out more by them, also go ahead and let me know if I should check out more by them. I just thought, okay, it looks like they got some interesting things coming up in here. Like look at this. Some of this stuff looks really interesting. The frogs turn black looks cool. I want to talk about this. That's design theory, which that's cool, interesting. So, like honestly, any of these look interesting. So go ahead and let me know if I should look at any of those kinds of videos. And we also have a membership program here on Americans Learn. You'll get some early if you can get some early access to things. So I think most of the videos that go up early access on this channel tend to be music related, but we can do other stuff. So yeah, there's that. If you all cannot support financially, leave a like, subscribe to the channel. Share it, tell people about it. Like, all of that helps us out too. Thank you so much for watching, and I will see you in the next video.